Okay, Year 9, I'm going to do the next exercise, the last exercise for the week. It's exercise 7H, and it is proving. Now, I did this in the last video for the last exercise. They only said explain, but I just felt that it needed to be a bit stronger than that. So we already have done proving. So if you're okay with doing this, you go and have a go at the questions yourself. What we're going to do is I'm going to do not all of them, but some of them. And we're going to try and do 4, 5, 6, and 9. Now, note how you set out a proof. All right? So, exactly the way we've been doing it, and then applying the similarity. All right, so here we go. 4. Now, I'm not going to do all of these, but I'll give you hints on how to do them. And the most important or the hardest ones are going to be when you've got triangles within triangles. So I'm going to do A, C, and E. So here we go. Here's question 4. A. Now the first thing, draw yourself a diagram. Label it A, B, D, C, E. Now, put on the information they give. Well, that and that are parallel. Now what you need to do is then in a different colour, because this is how you're going to go through your proof, indicate how you're going to prove. Well, you put on the information that you know. Well, you know that this angle and this angle are similar. And the way you indicate, are the same because they're vertically opposite. And just use the symbol. And you know that this angle and this angle are equal because they're alternate angles on parallel lines. See the Z? And by the same reasoning, this angle and this angle are equal. There's the same Z. All right? Oops, sorry. Here's my Z. Okay. So once you've done that, and you know how you're going to do it. So this one's pretty easy. So prove triangle ABE is similar to triangle BCD. Now you really only have to prove that two angles are equal and then you get equal angular, but I always do 3. So angle EBA equals angle CBD because they're vertically opposite angles, which are equal. Now, angle AEB equals angle BDC. Why? Because they're alternate angles on parallel lines. And finally, angle EAB equals angle BCD. And you can write similarly here because it's the same rule. Therefore, terrible therefore. Oh, come on, give me the rubber. Therefore, triangle ABE is similar to triangle BCD. Why? Because they are equal angular. Now they will use the rule that two angles are equal. That's just as good. So that's 4A. Nice and easy. I'm not going to do 4b for you. You need to have a go at it. But if I were doing it, I'd be going vertically opposite, alternate, 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 alternate. It's almost the same proof. Away you go. I want to do C though, because C involves drawing it separately. And I really want you to take your time with this. So for C. So I'm going to draw them separately. So I'm just going to draw this little triangle, and then I'm going to draw the big triangle. Okay? So I'm going to draw the big one first. And then I'm going to draw the little one. I know they're not quite orientated that way, but that's okay. So we've got A, C, E, and we know that that line, AE, is parallel to this line, and this is B, D, C. Now what else do we know? Well, we know that this angle and this angle are the same because they're common. It's the same angle in both triangles. And we know that this angle and this angle are the same because if I look back here, there's the F. Come on, get out of there. There's the F. So this angle and this angle are the same because they're corresponding. Give me the rubber. So, and by the same reasoning, this angle and this angle are equal. So away we go. And see, when you draw them separately, it just makes it so much easier. So our aim is to prove triangle AEC is similar to BCD, triangle BCD. Here we go. Everything about triangle ACE on the left. So angle ACE equals angle BCD. Why? Because it's common. It's the same angle in both triangles. Angle AEC equals angle BDC. Why? Because they're corresponding angles on angles on parallel lines. And then finally, angle CAE equals angle CBD for the same reason. Therefore, triangle AEC is similar to triangle BCD equiangular. Equiangular is just easier than writing all angles are equal. You can do it all in one word. So there's C. Now, there's my big hint. Whenever you're drawing two triangles, you've got a triangle within a triangle, draw them separately. So here we go. You have a go at D and E. We'll just try E. I'm going to do E here. So go away, have a go at 4E. Now, I'm going to draw the big triangle first and put in all the things I know. So what have we got? A, D, C. Put in the markings. Well, they tell you that that angle is that. And that's all they tell you. Okay, well, let's draw the other one. And well, that's pretty badly drawn. Let's get this down. This is pretty straight down here. Righto. And that's a triangle A, E, B, and they tell us that this is it. We've only got one angle. But no, you don't. Look, you know that this angle and this angle are the same. They're common. And then you can get this angle and this angle because angle sum of a triangle. So here we go. So prove triangle ADC is similar to triangle ABE. Okay, first one, let's do the common angle. Angle DAC equals angle EAB, common. Angle ADC equals angle ABE. Why? Well, that was given, it was part of the information, and therefore, finally, angle ACD equals angle AEB. Why? Angle sum of a triangle, you could write as 180. Therefore, triangle ADC is similar to triangle ABE, equiangular. Most of the time, when you do these, you will get equiangular. So that one was a hard one. You're going to do the same in the next one, ABD. You've got the two angles, they give them to you. Let's go down here to 5. Now, all of these are going to be the same. All right? All of these are going to be the same. So I'm going to do, I'll do 5B and C. And 5A, well, I'll do 5A and C. For the same reason. A and B are the same. Same process. So here we go. 5A. And this is a hard one. So again, I'm going to draw the big triangle. I'm going to label it A, C, E. And that's 9. And that's 6. Now I'm going to draw the little triangle. C, D, B. C, D, B. C, D, B. And that's 3, and that's 2. And straight away, that angle and that angle are the same. Now, we don't have any other angles. We can't show that any other angles are the same. They don't give us any parallel lines or anything like that. So we're going to have to use that unusual one where we've got two sides in ratio and the included angle is equal. So here we go. Prove triangle ACE is similar to triangle BCD. Well, how are we going to do that? First of all, let's get rid of the common angle. Angle ECA equals angle DCB. Why? Because it's common. Now here's the hard part. These two triangles are orientated differently. But if you just go, oh, I've got the angle, now the two sides I'll just go the bigger one to the bigger one. And I can do this all in one go. So watch this. So EC on BC. They're the two sides. That's 9 on 3, which equals 3. And let's do the two small sides. AC on DC equals 6 on 2, which equals 3. So you've shown that the two sides, so therefore triangle ACE is similar to triangle BCD. Why? Well, this is a long one. Because two sides are in ratio, the same ratio, you don't have to say the same ratio, and the included angle is equal. So that was quite difficult. Now, if you look at B, it's going to be the same. You're going to get this angle in both triangles, and you're going to get the long side, 48 on 12, that's 4, and 28 on 7, that's 4, so the sides are in ratio. So two sides in ratio, and the included angle, it must be the angle in between the two. Righto, so I'm going to finish off here with question 5C. Well, not finish off, but do it. Just think about seeing if you can do it before I do it. So here we go, 5C. Again, I really strongly suggest that you draw the triangles separately. So I've got this one, and I've got this big one. Label them D, D, C, and C, A, B. Well, what do we know? Well, this angle and this angle are equal because they're vertically opposite. Let's put the sides in. This is 2, this is 3, this is 5, and this is 7.5. And just remember, the longer side goes to the longer side. Okay, so here's our aim. Prove triangle DCE equals, is similar to triangle ABC. Well, how will we do that? First of all, angle DCE equals angle ACB, vertically opposite. Come on, give me my rubber. Getting messier as I go on. Opposite angles are equal. Beautiful. Now, let's do the sides. And I always like to do the bigger sides on top. It makes it easier. So I'm going to do, well, BC, that's the longest side and the big one, over DC equals 7.5 over 3 equals 7.5 over 3. 2.5. And the shorter sides, AC, over the shorter side, CE, equals 5 over 2, which I know is equals to 2.5. Therefore, triangle DCE is similar to triangle ABC. Why? Because two sides are in ratio and the included angles are equal. Okay. So that's question 5. I want you to have a go at 9 or 6 and 9 before I do them. So 6 and 9. Now 9 is used commonly in working out how far a river is, right? And 6 is how we work out the height of trees and distances between planets and all sorts of different things. So here I'm going to have it. You have a go at 6. If you need help, come back and watch this. So you draw a tree, and the sun's casting a shadow. All right, so the sun's up here. And I get a shadow. We're going to assume the tree is vertical. And it says the shadow is 20 metres long. Okay? But at the same time, exactly the same time, we've got a stick. And it casts a shadow, and the sun's the same, in the same spot, so far away, casts a shadow. And a 2 metre stick casts a shadow 1 metres long. Give a reason why the two triangles are similar. Find the height of the tree. So I'm going to put an X for the tree. I'm now going to label it. I'm just going to call that A, B, C. I'm going to call this D, E, F. Now, if I can show that they're similar, well, how do I know that they're similar? Well, the angle of elevation is the same. This angle and this angle are the same because the sun is casting the same shadow. All right? I could have drawn it. So here's the stick. I could have put the stick in here. Yeah? And made it. So the two triangles are actually in the same. So that angle of elevation is the same. So here's my aim. Prove triangle ABC is similar to triangle DEF. Okay. First of all, the tree is vertical. So C or BC, angle BC, oh, idiot. Angle ACB equals 90 degrees because it's vertical, which also equals angle DFE. Why? Because they're vertical. Angle BAC equals angle EDF because they're angles of elevation. I'm not going to go and prove the third one. I'm just going to say, well, two angles are equal. Therefore, triangle ABC, you only need two, is similar to triangle DEF because they're equal angular. Hence, now, thus, x on 2 equals 20 on 1. So x equals 2 times 20. Tree's 40 metres high. That's one big tree. I'm just going to go and check the answers. What are we doing? 40 metres. Righto. I want you to have a go at 9 on your own. All right? But think about this. Joanne wants to find the width of the river without crossing it. So she sets out 4 pegs, and she's on one side of the river, so this is common. So here you've got this triangle, and she sights a tree over the other side that she knows is directly opposite, so it's 90. And then she sets out this triangle. Now you think about it. What do you know? Well, you know that these two angles are equal because they're vertically opposite. That angle and that angle are 90, all right? And then you go, x is going to correspond to the 8. X on 8 equals 30 on 12. So x equals 8 times 30 on 12. And I get 20. And I'm looking at question 9, 20. All right? Now, you should go through and prove all that. But once you know, right, once you know that the triangles are similar, and by the way, 20, away you go. And here you can see they've done it again. So, there are our proofs, and applying those proofs with similarity. Good luck with those.